Hi, everyone. This is Amit. I'm a senior software engineer in the static analysis group, and today I'm going to give you an overview and walkthrough of one of the features that we have been working on in the past few milestones. We have had this feature released as an experimental feature for GitLab dedicated users in 16.7, and we will work on making it available for other types of instances in the future as well. But let's talk about what we have shipped so far in 16.7, and we will also get a chance to go over some of the enhancements and improvements that we have lined up in upcoming milestones. And I will also try to do a demo of the feature. So let's start with me sharing my screen. We could or we could start here by looking at, or as an overview of what the pre-received secret detection feature do. We scan contents of files that are committed and pushed to a remote repository. This happens so that we prevent any accidental leaks of secrets and API keys, for instance. When these secrets are detected, the git push is blocked and you will get an error message, as we will see later on. So that's in a nutshell what this feature does. We in 16.7 we have worked on a number of things to make sure that the feature works in a nice way for customers and users. And one of this this initiative thing, or like one of the things that we have done, is to have this instance level configuration, which allows you to enable and disable this feature per the instance. Obviously, and this happens through the admin interface. So an administrator of your GitLab dedicated instance can turn it on and off for the entire instance. Let me show you a quick, I wouldn't say demo, it's just like, showing you this option. So if we go to the admin area of your GitLab instance and you navigate to the settings, security and compliance, you will see that we have this secret detection section. And if we expand it, there is this checkbox that that can be used to enable the feature for the entire instance. Maybe to share some reasoning for why we did this. The initial plan was to put the feature behind a feature flag, but unfortunately for dedicated instances, feature flags are not available, and the idea was to use some other type of configuration to enable this on and off, or like to turn this on and off. Our plans for the future is to have this or like provide more granular control over this, so that the feature could be turned on and off per group and per project as well. But for the time being, on dedicated instances, this is the best way to enable the feature. So moving on, there were a number of other things that we have had included in 16.7. And one of them is making sure we have good range of regex patterns that we match secrets against. If we look here, you see that we have a number of well-defined GitLab tokens. In addition to this, we also have some partner verified tokens that we check against. So this is the initial list of patterns that we match against at the moment, and is included in 16.7. Another thing that we have worked on is ensuring the metadata for a specific secret finding or like specific finding is displayed when push is rejected. This metadata usually includes the commit SHA and also the file path in order for the user to understand more about how or like where to find the secrets that has been detected. So another, yeah, that's one thing. And the last one that I would like to discuss here is a bypass mechanism that we have included in order for the users to, in cases where like, I don't know, you're working on, as a customer, sorry, as a user, you're working on like some tests that you want to include in your project, and these tests are using like some sort of a dummy secret, for example, that you are sure is going that you wouldn't want to have detected, so to say. In such case, there is a way to skip the secret detection or the pre-received secret detection by including a special commit flag, as we will see in the demo. So these are the main things that I think are worthy of mention in what we have shipped so far in 16.7. And with that said, I would like to give you a small demo. Let's imagine we have this small project that we are working on. In this project, we have this .env file where we are going to store some environment variables and maybe secrets as well. Yeah, don't do it. Don't store secrets in .env files. It's a bad practice, but I mean, like, you get the point. For the sake of the demo, we are going to do that. Let's imagine we are building like some sort of an e-commerce website, and we're going to use Stripe in order to build this. So yeah, let's say we have a token here, and we go here, we copy like this example token from Stripe documentation, we add it here. And let's commit this. Now, before we run git push command, let's talk about the things that will happen when you run this command git push. Behind the scenes, the pre-received secret detection, it's attached to a webhook. Sorry, it's not a webhook. It's attached to the pre-receive hook, a git hook. And what happens is that as soon as we as soon as the push is received, before it is committed to the repository, we start like making the secret scanning, or like we start detecting the secret. And what happens is, if a secret is found, we reject the push and an error is displayed. So let's try to run this command and see what happens. As you see here, the push was rejected. It didn't go through, and we have received an error message including some information. It says that the secret detection scan was complete one or more findings, and then it points to a secret that was leaked in this commit, the one we just tried to push. We also show, as we were discussing earlier, we are showing the file path in which the secret existed and the line number for the secret. In addition to that, we also have the type of secret that was detected. And as you can see here, part of the message, there is like this advice on how to skip secret detection in case there is a reason why you would want to skip secret detection. In such case, you are advised to add this special flag in your commit, in one of the commits that is part of your changes. So let's try to do this. Let's amend the commit. And we will just add this special commit flag here. Sorry. Now that we have updated the commit, let's try to push again. When we try to push again, this should go through and there will be like no error messages and the push will not be rejected or blocked. This worked. If we go back here again and check, the file has been committed with the secret. So this is more or less the demo that we have that I have planned to show you so far. There are like a lot of upcoming enhancements that we are planning to build on top of this. The things that I the things I wanted to mention earlier is a number of enhancements that we have in the pipeline already. Some of them will land in 16.8 and some others maybe later. But the two that I want to talk about briefly is, there are three of them. I want to talk about all of them briefly. The first one is we have shipped actually performance optimization that reduces memory usage when doing the secret detection scanning. This have already been merged to 16.8 or would be available in 16.8. Another one is related to the message we display when push is rejected, which will now have a link to the documentation in order to give the user some kind of guidance on what to do when the push is blocked. So these two are going to be in 16.8. Another one that we have been working on as well is enhancing how we display multiple findings if there are a number of secrets in the same Git blob. So let's imagine you have a file. The file has multiple secrets committed. At the moment, we would show some of these findings. We will display all the findings, but some of them will be shown with perhaps not enough metadata, like the commit ID or commit SHA, as we were discussing earlier, and the file path. But we would still show as much information as we have, for instance, the line number and also what type of a token is it. So with this enhancement or this improvement that we have been working on, we should be able to display the metadata for all types of findings, or for all findings we would find in a single Git blob. So this wraps up the things the things I have wanted to discuss today. We talked about what we have shipped so far, and we also did a quick demo of the feature in action. And finally, we talked about some of the upcoming enhancements we have. That's all for today. Thank you so much for watching. Stay tuned to learn more about other upcoming enhancements in the following milestones and iterations as well, also as we move from experimental to beta sometime soon. Thank you. Bye.